Let's make some modifications to our input file. As opposed to the previous simulations we've run, where the number of agents within the network remained constant throughout the simulation, we're going to have the number of agents within the simulation increase over time by setting our initial agents to 10 and our max agents to 1000. Most importantly, we're going to set use Barabasi to true, causing the simulation to implement the Barabasi configuration. Barabasi connections specifies the number of connections an agent makes when entering the simulation. So for this classic Barabasi example, we're going to set this value to 1. Since we are running a Twitter suggest follow model, we're going to set the follow model as Twitter suggest. In the rate section of this input file, we're now adding agents to the network throughout the simulation. So we will change the add rate value to 1.0, so that one agent will be added to the network per simulated minute. This add rate is much lower than its actual value, where users join Twitter at a rate of about 100 per minute, but we will use this value for this tutorial. As mentioned in the previous tutorial, the follow ranks are essential to the Twitter suggest follow model. Agents are placed into bins based on their in degree or the number of followers they have. All the agents in the bin with threshold 0 have 0 followers, while all the agents in bin 200 have 200 followers. The weight of each bin threshold determines the probability that an agent from this bin will be randomly chosen to be followed in comparison to agents in other bins. The bin thresholds are linearly spaced in increments of 1 and have a minimum value of 0 and a maximum value equal to the maximum number of agents within the simulation. This value, of course, doesn't necessarily have to be exactly equal to the maximum value. It could, of course, be greater than that value. It just must not be less than the maximum number of agents in the simulation. As you can see here, we have a value of 10,000, while the max number of agents in our input file is 1,000. The weights of these bins are also linearly spaced in increments of 1, and the minimum bin threshold has a weight of 1, and the maximum bin threshold has a weight equal to this number increased by 1. Therefore, the weighted probability that an agent with 10 followers will be chosen in comparison with an agent with 100 followers is 11 to 101. So agents with a greater number of followers have a better chance of being followed by other agents. It is thus very important that the max follow rank threshold be equal to or greater than the number of max agents within the simulation. If this number is less than that, your network simulation may give inaccurate results, and the total number of followers the most popular agent has may be impossible to determine. Since the minimum threshold follow rank has a weight of 1, the maximum threshold follow rank must have a weight equal to its value increased by 1. This is assuming the increment is set to 1. To better demonstrate the results of a Twitter suggest follow model, we're again only going to use standard agents in this simulation. It is imperative that we have also set the standard agent type's follow rate to 0.0, so that the only manner in which agents are connecting with each other is through the Barabasi connections they are assigned to make.